This is chapter 2.3, exercises 33 through 36 and 39 through 40. This set has to do with polynomial functions, finding the zeros of polynomial functions, making sketches of graphs of polynomial functions, multiplicities of these zeros, so different aspects of polynomial functions. And exercises 33 to 36 find the zeros of the function algebraically. So to do that, there are different ways to do that. You can use a quadratic formula. Probably the easiest way to do it, algebraically if you can, is to find the factors. And that would be to rewrite this function in factored form. And when you find these factors, it's going to be easy to use the zero factor property and find the zeros. Now, usually a quadratic trinomial is going to have as its factors two linear binomial factors each. And it's a matter of finding out what those factors are. Now, one where you have a leading coefficient, the coefficient of x squared is 1, you can just pretty quickly fill in and do a guess and check. When I'm starting for the new year, I like to go ahead and take the box method, which just kind of breaks it down. It's kind of training wheels. In the upper left corner, we put this first quadratic term. In the lower right corner of the cell, we put the constant term. And so we have this x squared term goes here. The negative 8 is going to go here. Okay, so that's where those come from. Next, we find the factors of x squared, which are going to be x and x. That's pretty evident. Now you're looking for the factors of negative 8, which when added together equal this coefficient of the linear term, 2x. So, that's going to be 2. So two numbers multiplied together equal negative 8, but when added together equal 2. And just to go ahead and fully articulate and explain, one thing you can do with these is you can make a list of factors. And the factors of negative 8 are going to be, well, you can get that by taking negative 4 times 2, negative 2 times 4. You can take negative 1 times 8, and also negative 8 times 1. Now, adjacent here, I'm going to put something I abbreviate as SOF. SOF is an acronym for sum of factors. Put this down, sum of factors. And so just adding here, negative 4 plus 2 is going to be negative 2. Negative 2 plus 4 is 2. Negative 1 plus 8 is 7. Negative 8 plus 1 is negative 7. And so now you look at the coefficient of our linear term, which is 2, as in positive 2, and you look at our sum of factors and see where that exists. Well, it's going to exist right here. And accordingly, our factors for this negative 8 are going to be negative 2 and 4. We could put them in opposite places. Now, if we multiply negative 2 by x, we get negative 2x, and 4 by x, we get 4x. And we have, if we combine these like terms, we're going to get positive 2x. So that we're going to have x squared plus 2x minus 8. So that's a check. So we're sure that our factors for this are going to be quantity x minus 2 times quantity x plus 4. Now, are we done? No, we are not done. And the reason we're not is because, and if you're kind of lazy about it, you say, well, the zeros might be negative 2 and positive 4, but that would be incorrect because you need to find, for zeros, you need to set this equation equal to 0. So I'm going to come up to the right here and rewrite this. Instead of f of x, I'm going to write 0 equals quantity x minus 2 times quantity x plus 4. And because of the zero-factor property of algebra, there's going to be a solution where x minus 2 is equal to 0, or where x plus 4 is equal to 0. And if you solve both of these equations, I'm solving the one on the left by adding 2, x is equal to 2, and this other one we have to subtract 4 from each side. 4 minus 4 cancel. We have x is equal to negative 4. So x equals 2 and x equals negative 4 are the zeros that we have discovered algebraically. And there we go, x equals 2, x equals negative 4. Okay, next, 35. We have a degree of complexity above what we experienced earlier in that we don't have a number 1 as our coefficient of x squared. So we got to work with this 9x squared, which is going to increase our complexity. I'm going to do this a couple different ways. I'm going to do first like we did in problem 33, just create a box. When you do it this way, and you can require a little more guess and check. So we're going to take that first term, 9x squared in the upper left and negative 2 in the lower right. And really, it's for the negative 2, that's pretty easy. You're going to have, it's going to be negative 2 times 1 or negative 1 times 2. So either one. But for 9x squared, we can just try 3x and 3x as our factors here. And then we can just try different factors of negative 2. So if we try negative 2 here, and we put 1 here, we get negative 2 times 3x is going to give us negative 6x. And then 1 times 3x is 3x. And then if we add these two together, we're going to get 9x squared, and then 3x minus 6x is going to be minus 3x minus 2. So that's going to be a check. And so we are sure that our factors for this are going to be 23x minus 2 and 23x plus 1. And again, as we did in problem 33, we have 3x minus 2 is equal to 0. And the other factor, 3x plus 1, is equal to 0. And if we add 2 to both sides of this left equation, we get 3x equals 2, and dividing by 3, we get x equals 2/3. So that's going to be one of our zeros. And then this other one, if we subtract, I don't have a lot of room here, so I'm just going to kind of abbreviate. If we subtract 1 from both sides, we're going to get 3x is equal to negative 1. And then dividing by 3, we get x is equal to negative 1/3. So that's our other factor, or other zero, excuse me. And so that would be that. Now there's another method called bottoms up, where for factoring, like if you have this 9x squared minus 3x minus 2, you multiply a and c together and you get 18. And so 9 times 2 equals 18. So now you rewrite this as x squared minus 3x minus 18. Okay, it's going to be 9 times negative 2 will be negative 18. And then we find the factors of this, which are going to be quantity x minus 6, quantity x plus 3, and then we go ahead and divide by our original 9 here, and 9 here, and we get, just simplifying, we get this is going to be equal to quantity x minus 2/3 times quantity x plus 1/3, and then bottoms up we're going to take this 3, and the bottoms up we take this 3, we can't simplify to an integer, so we're going to get 3x minus 2, and then we get 3x plus 1, and you realize that's what we got. We can factor from there or find the zeros from there. So anyway, that's problem 35. Next on our problem 39, exercise 39-42. State the degree and list the zeros of the polynomial function. State the multiplicity of each zero and whether the graph crosses the x-axis at the corresponding x-intercepts. And sketch the graph of each polynomial function by hand. Well, for this, we're going to go ahead and swap f of x for 0. So we have 0 equals x times quantity x minus 3 squared. And using our zero factor property, we know that x is going to be equal to 0. And on the right side here, we have x minus 3 is equal to 0. And solving this right one, we add 3 to both sides of the equation. We get x equals 3. And we see this x is x to the first power, so that's going to be, okay, we found the zeros, and we've listed them, x equals 0, x equals 3, and we have x to the first power, so we say multiplicity, which I'm going to abbreviate MULT, equals 1. And then we have, for this x equals 3, we have this quantity x minus 3 squared. So for this, our multiplicity is equal to 2. It also says state the degree. That was the first thing they listed. I didn't get that first. What you have, just for degree, you have x, and then this quantity x minus 3 in parentheses, we're going to have x squared. And so x times x squared is x cubed. So for this one, our degree is equal to 3. So we have a degree of this polynomial function equal to 3. We have x equals 0, and this particular 0 has a multiplicity of 1 because that 0 occurs once. And the 0 x equals 3 has a multiplicity of 2. And so we can go ahead and mark on our graph here at x equals 0 and at x equals 3. And as far as it says, and whether the graph crosses the x-axis, well, for an odd number multiplicity, we know this 0 here will cross the x-axis. If it's a multiplicity of an odd number multiplicity, so we'll say x equals 0 crosses x-axis. Another piece of information. And also this one here, x equals 3, well, that's a multiplicity of 2. An even number multiplicity will not cross the x-axis. So our 0, x equals 3, does not cross x-axis. again because that's an even number multiplicity. So here we have the degree of 3, we have what the zeros are, their multiplicities, and whether or not they cross the x-axis. One in one place the function does, the other place the function does not. And now we're going to use these zeros in this knowledge. So we have an odd degreed positive function. So we're going to start down in quadrant 3 and end up in quadrant 1. And what that's going to look like, we're going to come from way down here, from greater than negative infinity, and we're going to, now 0, it's going to cross the x-axis. Right? That's what it says here. Crosses x-axis. And we're going to come up here, and this other 0 at x equals 3 does not cross the x-axis, so it's going to just hit the x-axis at x equals 3 and kind of bounce and then go up like this. So this is just a general sketch of the function. If we look at this in a calculator, you'll see something very similar to it. Good luck on these even number problems, and thanks for viewing.